This is section 12.5, the final section in chapter 12. And chapter 12 is about not only the existence of two variables as we did in section 4 with the routes and the drivers, but also what if the time that drivers take across the different routes is influenced by the driver himself or herself. What if some drivers are better in certain routes and others are maybe in other routes? The first thing that you need to do is, and now going back to the previous section, here we had originally the four routes and the average speed of each driver on each route. If you just block this, you can get a graph that will show the possible interactions, so-called, which is the main topic of this section. So you insert, just highlight your data, including the labels. Then you go to the insert line chart. Select the one with the little dots here that separate one observation from the other. And if you notice, we have the reverse actually of what is shown in your textbook on page 406. Let me increase this. Now, one thing we can do is just go to design here and switch the row columns, and automatically will invert the order of the axis. And now we have the same data, the same interaction plot that is shown in your textbook. You have the different colors here. These lines are the different drivers, and these are the 1, 2, 3, 4 different routes. So here on the blue one, for example, what we have is Mr. Dean's here, or Miss Dean's. And the first point here is the amount of time that Mr. Dean's, let me just call them Mr. Dean's, Mr. Dean's take in US 6 route. And then on West End, it takes this person this amount of time, which is 17. And then Hickory Street, it takes this person 21 and 22 on Route 59. And also notice that Mr. Dean's is also the driver that has the lowest amount of time across. But the red one here crosses with Dean's, and that red one belongs to Snavely. So Snavely is actually lower, has a lower time for US 6. And then it crosses with the yellow and the gray here on the towards the second West End. And so you see some degree of interaction. That is when these lines cross. If there is no interaction at all, then these lines will not cross. So the test that we're going to run now is to test whether there is not enough interaction across the drivers and routes. And that is what is shown on page 406. All right. Here we have, if you notice, more observations per driver. So the drivers were made to take each route again 2 more times. So we have, this is the average that was shown before. We have 2 more observation of 2 more times that were taken. Okay, and these 3, and if you read carefully, and this is important because of the language used, these are the number of replications per cell. So when you see that language in an exercise or a homework assignment, number of replications per cell means number of observations you're going to see per driver in this case, okay, or per variable in the first columns here across the rows. So you're going to have 3 and 3 and 3 and 3, and we have 1, 2, 3, 4, 5 drivers times 3 equals 15 per route, and we have 4 routes. That means a total of 60 numbers observed. So now we're going to test whether there is actually any significant interaction among drivers and among routes. So just again, go to data, data analysis, and select now ANOVA two-factor with replication and click OK. Now let's input the range and rows per sample. I'm going to put 3. That is what is called sales interaction or sales replication. And in the output range, I'm just going to select right here my output range, and I'll get a certain output first per driver. And now what I'm interested in more than anything is my ANOVA table at the end. All right, let's look at each one of these carefully. What we have here is a word sample. Notice that next is columns and then interaction. And then within variation, which is the error that we had before. A total variation of 929.65. And remember the degrees of freedom is always n minus 1. We had 60 numbers, minus 1 equals 59. All right. So now what are the sample? Or what is the source of variation called sample? Well, if it's not the columns, this just be these are the rows or the drivers. Okay, so across the drivers, the sum squares is 353.56. The degrees of freedom are 4, which is 5 drivers minus 1. 5 minus 1 equals 4. All right, across the columns, the sum of squares is 244.98. The degrees of freedom 3, which are equal to 4 routes minus 1, the same that we did before. Now the interaction factor. The interaction has a sum square of 125.76 and the degrees of freedom are 12. So across interaction, the degrees of freedom are equal to n minus 1 times, or I'm sorry, b minus 1 times k minus 1. Okay, so it's just these two numbers multiplied. So that is the number of degrees of freedom assigned to the interaction. If you recall in the previous section, that was the number of degrees of freedom assigned to the error. But that was when we did not have an interaction. And finally, the error here, the within or residual that I called before, has a number of degrees of freedom equal to n minus k times b. So there are 60 numbers minus k times b. 5 times 4, that is 20. K, remember, is the number of columns and b is the number of blocks or the rows. So 4 times 5 equals 20. So 60 minus 20 equals 40. And again, the degrees of freedom for within is n minus k times b. And as I said in the previous section, you can also calculate the degrees of freedom of within or the error by taking the total degrees of freedom and then subtract the 4, the 3, and the 12. That should give us 40. And again, the mean square here of the sample of the rows is equal to 88.39. The mean square of the columns, 81.66. The mean square of the interaction, 10.48. And the mean square of the error, 513, the MSE. And then we can calculate now the F statistics. Remember, this is the ratio of variances. The first variance divided by the MSE, the second divided by the MSE, and the third divided again by the MSE. That's how you obtain the F statistics. So 88.39 divided by 513 equals 17.21. And then 81.66 divided by 513 equals 15.9. Finally, 1048 divided by 513 equals 2.04. So these F statistics are going to be compared to a critical value, which is shown right here. And that critical value, this is at 5% significance level test. The critical value is 2.6. The F statistic is much larger than 2.6. Therefore, across sample or the rows, in this case the drivers, we have the F statistics greater than the critical F, So therefore, we reject the null hypothesis. You can see the p-value is much less than 0.05. P-value is 2.74 with 8 zeros to the left. And therefore, we reject the null hypothesis, which suggests that the means are all equal. So we conclude, in other words, that the means are not equal. And the same we conclude for the columns of the treatment, because 15.9 is greater than 2.83. That is the rejection area, so we reject the suggestion that means are all equal. In other words, we conclude that the means are different. And actually, if you recall, this is the same conclusion we reached from the previous section. Now, the interaction. The interaction is also tested the same way. We compare the F statistics with the F critical, and it is, if you notice, barely above the F critical. So, and the p-value is also barely below the 5% significance level. But it is the conclusion then that the null hypothesis needs to be rejected too. So there is interaction. It is not very, very strong interaction, but it is strong enough to reject the null hypothesis that suggests that there is no interaction. So we conclude again that there exists interaction among drivers and routes, or between drivers and routes. That is the end of my illustration of section 12.5.